Welcome to Calculus. This is Lesson A, which is a big review of a lot of algebraic concepts. And the reason for that is because it's hard to do calculus without algebra. In fact, calculus is where you actually use the algebra concepts that we've been telling you you're going to use for the rest of your life. Now, example A.1 and A.2 are very similar, and we're going to work both of them here in this video, or at least set them up in this video. And the key here is that you're working algebraic problems that do not have any numbers in them. And the reason for this is simply so you can practice. Now you'll notice you are solving for C, but at this point that really doesn't matter because we're just going to set this up in a simple way where we can hopefully get this to work. And the key here is to get rid of your parentheses first. So multiply that V out. So you end up with Y equals V times A over X plus V times B over MC. Now there's that C that you're going to be solving for, but once again that really doesn't matter. And now comes a very interesting process that a lot of people forget about that you can do in algebra. Anytime you have an algebraic equation, meaning there is an equal sign, you can always multiply both sides of the equation by the common denominator and it will cancel out all of the denominators. Let me show you how that works. In this case, our common denominator is xmc. So if we multiply both sides by xmc and multiply everything by xmc, you'll notice something really neat happens. All of the denominators will go away. Of course, the left side will simply be y xmc equals VA. Notice the x's cancel out, and that's why the denominators are going to go away, because now you have VA MC plus, and now MC will cancel out, and so you have VBX. This problem is now a lot simpler because everything is on the same level. There are no denominators. Now is where you have to worry about what you're solving for. Notice we're solving for these C's, and there are two of them, so let's put them on the same side. So we'll have YXMC minus VAMC. Now remember, this is a simple algebraic process of whatever you do to one side, you do to the other. Technically, we are subtracting this term from both sides. Now, in order to solve this, we do one more algebraic concept, and that is simply to factor out the term we're solving for. So if we're factoring out C, that's what we're solving for, we'll say C times YXM minus VAM. And of course, that will all still equal VBX. And now, in order to solve for C, we simply divide both sides by that complicated term there. And this should be our answer, assuming that there's nothing that we can cancel out. Remember, in order to cancel anything out here, it has to be in both the numerator and denominator, and in every single term of the numerator and denominator. And since nothing meets that criteria, that will be our answer. Both of the problems in example A.2 illustrate the same algebraic concept, and that is when you have multiple levels. And when I say multiple levels, I mean multiple fraction bars. Notice in this first problem we have fraction bar there, fraction bar there, fraction bar there. In other words, we have fractions within fractions. In order to fix these, we need to just focus on one section at a time. And so what I'm going to do is just section this off. We're just going to look at this section right now and try to simplify it. If I gave you that problem, it would be very simple. You would just find a common denominator and add. Our common denominator here, of course, is D, and so we multiply the parts that don't have D as a denominator by D, and we get D over D plus C over D. And of course, that comes out very easily to D plus C over D. I'll erase this and just write that out. So this part here becomes D plus C over D, and that takes the place of this section. Now, if we write the whole thing out, and I'll go ahead and show you how that looks. We now have a very simple process of looking at this as our new fraction that we're working with. And if we're looking at just that part of our fraction, we can do something very, very simple. And that idea is to take the denominator, invert it, and multiply it by both the numerator and denominator. that would simply look like this. Now the idea is if you multiply both the numerator and denominator, and remember we're only working with this section of the problem right now, we're not worried about the rest of it. If we multiply that out, notice the denominator completely cancels out, and now we are simply flipping it to the bottom. You may remember having done that before. It's the same idea of flipping the denominator to the numerator. You're multiplying both the numerator and denominator by the inverse of the denominator. Of course, that little section simply comes out to md over d plus c. If we write all of that out within the context of the problem, it ends up looking something like this: x over a plus, and then this section that we just worked on, md over d plus c. We can repeat this process and do the same idea over and over and over again. Now we find a common denominator right here. D plus c, of course, is our common denominator, so it comes out to AD plus AC plus MD all over D plus C. That's after we found a common denominator and then added, and then all of that is under x. And once again, we multiply the numerator, which is x, by the inverse of the denominator. Once again, what happens is we multiply the numerator and denominator by the inverse of the denominator. It cancels out down here, and we're left with x times d plus c over AD plus AC plus MD. I ran out of space on the edge of the screen there, but it's still the same idea, and then you can distribute that x. I'll let you look in your book on page 3 to see how you finish out that particular problem. The B exercise here works exactly the same way. The only difference is that you need to combine your fractions before you can flip the denominator to the numerator. And remember, when I say flip the denominator to the numerator, I simply mean invert the denominator and multiply it by the numerator and denominator. Let's work with the numerator first. We need to figure out what our common denominator is. You'll notice that there's an x squared and an x, so x squared is going to be our common denominator. So we're going to leave that a all by itself. We're going to take that b, and of course we need to multiply it by an x to make the denominator x squared. So that's bx, and all of that is over x squared. That's just doing it all in one step. The denominator, of course, is going to be x squared and xc, so our denominator, common denominator, is x squared c. Of course, that means we need mc, because we had to multiply that first term by c, plus kx. All it was missing was an x. Now I'm going to make sure I make this fraction bar right here very distinct so that I can tell it's the primary fraction bar. We just have a numerator fraction and a denominator fraction, which of course we need to complete with our common denominator. From here, once again, we just multiply the numerator and denominator by the inverse of the denominator. Here's what that looks like, and of course that means the denominator will completely cancel out, and we basically just flipped it to the numerator. Now remember to go ahead and distribute these, see if there's anything that needs to cancel out. Remember, once again, it's got to be in every term of the numerator and denominator, and I'll let you check out page 3 to see how that one finishes out. In the next videos, we're going to look at the rest of Lesson A.